Hello.
Yeah, I can hear you.
Yeah. Sir, so basically, sir, when the machine learning model give accurate prediction for training data and but not for new data, and model perform well in the training but not in the testing. So we can consider like this is the overfitting problem, and we can prevent overfitting problem with data augmentation, feature selection, cross validation,
What do you mean by
regularization.
data augmentation
So
in this
data
scenario?
augmentation means we are changing the position of a particular image or something different
Okay.
position.
Suppose you
मतलब
don't
like
have an image. Suppose you have columns of data, right? It's not an image-based problem. It's a column problem. So what data augmentation would you do in this case? Like this is open to everyone.
Sir, basically data augmentation is a term which we use in case of the pictorial representation, but right now you're asking for the data set. In that case, we actually artificially increasing our data set, and for that we can go for basically the uh, statistics model, in which we can artificially create the medians and we can add on to our original data set,
so
because median. Hello.
So can we add dummy data?
Yeah. So see, what you said is right, but you have to
I would
understand
like to add one
Yes,
thing
sir.
here.
Yeah.
I also want to add one thing, sir.
Ruchi, go ahead.
Yes, so sir, we can avoid overfitting by reducing the dimensions or by reducing the columns by selecting the best features out of the various columns.
But isn't that like counterintuitive? Like, some of you say like increase the features, increase
No,
the
no, sir.
this,
Increase the
and
feature
then
is
you say
not the
decrease the features.
increase the feature is the problem again. It will create the overfitting because we need to restrict our data.
Correct. So in
Yes, sir.
Google or something, you might see a larger data set would reduce in overfitting.
Yes,
That
sir.
is also correct. But if you're doing like median or something like that to artificially increase your data or dummy variables, it will increase overfitting because
Yes.
you are giving the same data again and again in a
Yes,
different
sir.
format.
Yes, sir.
Right. So the model just thinks, acha, ye bhi hai. So it's the same thing, just in a different format. What is dummy variable? It's the same thing in 0 and 1.
Sir, we
Okay,
can go for the undersampling.
Yeah, okay. Yeah, undersampling is a good thing. So I'll just give a couple more things on that. So as we can see here, overfitting occurs when a model is trained too well and it does not perform well on test data. So overfitting, as some of you said, a model is too complex and it starts to fit noise or random fluctuation in data. So if you say you will add noise, it will just give more overfitting. It won't actually, in most cases, it won't be helpful. In underfitting, you can add more data.
Yes, sir.
So that, it is trained well on the training data. But anyways, so this can, result in a model which does well on the trained data, but very bad on the test data or the real world data. Right. And it is a very big problem in machine learning and happens everywhere. And some of the techniques is, I'd say again, like we all said some techniques, those are very good. Like cross validation was one of them. But to do questions again and again, you have to learn more things, right? So for example, regularization. So what is regularization? It is just, it restricts the overfitting criterion, right? It generalizes your model so that it does not, goes too complex in the training data. And so cross validation, you all already said. Early stopping is another method So suppose you're training a model for like 100 rounds. In 100 rounds, it overfits. Like it is fitting again and again till 100 times. It is overfitting till 100 then. So if you set an early stopping criteria, it should only fit 30 times. If it has the best accuracy at 30 times, then just stop it. Don't train it again and again, so it won't become more complex. Or very simpler example is like using simpler model like logistic regression, linear regression. But this is not that heavily recommended because your model would be too simple. Okay, does anyone has any doubt in this, or we can just move on?
So we can also use dropouts, right?
Yeah.
Yeah.
So that also helps. Yes, that's good. Okay. Again, like the goal of this session is knowing a little bit more than you already do. If you know other methods, then it is superb. Because as I said, interviewer has some, technique in his mind that he wants you to say. So if that technique is drop out, then you will be good. But if that technique is regularization or cross validation, then you would be like, you won't pass the interview, to be honest. Right. Okay, moving on.
Okay.
Okay, what is bagging and boosting? Like anyone who has an idea on this? Sorry, like, do you know about it a bit? Like, whatever you know, you can say.
Bagging boosting is a part of ensemble learning where we do where we use 2 or more algorithms, and in that case,
Yes, sir.
the error of first algorithm was covered by the second algorithm and helps to achieve more accuracy. So it's a part of ensemble learning. I just know that. I don't.
Hello, sir.
Yeah, hi.
Sir,
Devinder, go ahead.
इसकी भैंस के मैं पूरा म्यूट पे बोल गया यार.
I think, sir, in bagging, we are trying to reduce the variance part in the data, and in boosting, I think not variance, but I think we are trying to reduce biasness. I think so that model will perform better, sir. I don't know.
So,
Sir.
okay, so we'll see. Right.
So I
let
can
me
say
just,
that
yeah.
it's a part of ensemble learning. Okay.
Mhm.
Okay, and in which the where we use 2 or more algorithms, in which the error of first algorithm was corrected by the second algorithm and helped us to achieve more accuracy. So bagging
Yeah, that's
boosting
sort
is
of
a
correct. You are explaining one of these concepts right now, so partially correct, I will get. So okay. No worries. It's the goal of this session is to know more about everything, right? So I'll just move forward with the answer. Firstly, why we use bagging and boosting? What is wrong with normal models? What is wrong with normal models is every algorithm has a certain criteria and it just runs once. Okay, so it might be good, it might be bad. Now, under bagging and boosting, as Gaurav said, it is a part of an ensemble learning technique where we have multiple models, right? Like 10, 20 different models, or we call it as weak learners as well. So the advantage of this is we have like 20, 30 different models and they are trying to make a better prediction than your one model or one decision tree what would have already made, right? So bagging just stands for bootstrap aggregating, where several weak learners or base models are trained on many subsets of data. And then the output of these models is then used by a voting mechanism by which we vote what would be the result. For example, there are 10 models, 10 individual weak learners, 7 said, the classification output should be 1. preset the classification output should be 0. So this is called a vote, and 7 is greater than 6. Thus the 7, what the 7 predicted, that the classification output should be 0, wins, right? Or 1, whatever the highest 7 predicted. Now, boosting does the same thing but in a different manner. So it also has a couple of different base models. But here the concept is the first base model could differentiate some part of the data, like suppose the 70% of the data, and 30% it could not make proper predictions, right? So this 30% is then sent to another, the next model, the second base model. So out of this 30%, the second model says I can only predict properly 10% out of it. And the rest 20% I can't predict on it properly. So the next 20% goes to the third base model. And like this, the weights of the remaining, the 30%, 20% are increased. And so that the next models would give it more attention. And thus you have a complete good model. And boosting is useful when the base model has a low bias and high variance model. Right. So it actually decreases variance. Both the models kind of tend to decrease the variance caused by the main model. So both bagging and boosting are powerful techniques, and it just uses multiple different models to make predictions. And this is actually used in like industries, like my company uses these kind of models so that we can make better predictions. So the main difference between it, if you can see here in bagging, the multiple models output is then ranked here. If you can see my cursor, right? And they work in parallel. Bagging always works in parallel. All 10 different models will work in parallel, and they will give a vote. Like I classify this as 0, I classify this as 0. This will say I classify this as 1. Now boosting will take the data, predict on what, train on data which it knows best, and the rest which it couldn't train or couldn't predict properly, go to the next model. And then the next model says, I can't train this one properly. Then it sends to this model, and finally the last model just takes all the rejected ones and trains them. Right. So this is parallel. This is sequential. Okay. Does anyone have any quick questions? I'll just answer them and move ahead.
Hello, sir. Can we say the bagging is a part of boosting?
No, bagging is not a part of boosting, because in bagging, you can see here, like suppose these 3 different models are trained in parallel. Like we sample this data, some will go in this, some will go in this, and some will go in this. And these 3 models don't know about each other. They just make
Different
at the same time.
Okay. They are different.
Yeah. And in boosting, only the ones which are rejected by the first model, I can't train on this properly, is sent to the next model. Then this model just takes this and tries to predict on it. So basically, there should not be any subset of data left where the model can't predict properly.
Okay.
So can you go back to the slide where you explained bagging? Okay.
Sure. Yeah.
Next one, please. Okay, sir. Thank you.
So that I'll just move on ahead. Okay, this should be a simpler question. What is collaborating on content-based filtering in recommender system?
Sir, before proceeding to this question, can you please explain what is bias?
Okay, so let's skip that. Yeah. So what is variance and bias? Right? You can't learn one without the other. Variance just means your model has like trained complexly, like it has fit all the patterns, even the noise patterns. That is variance. Now, bias is the opposite of it. Bias is too simple. Like variance goes deep into the data and search for patterns. Bias is like chilling on the outside his house. It just learns 1 or 2 patterns and that's it. So that comes in underfitting. Underfitting basically means it does not fit well on the trained data. So the bias is high. Like it did not fit properly, it underfitted. It just matched like 1 or 2 patterns and that's it.
Then how can we say,
so-
how can we differentiate? Sir? It has a low bias or high bias.
So the basic point of differentiating is your model complex or not? So basically, if I say a linear regression model versus HVM or a decision tree model, which would you think is more complex? Like you have seen linear regression, right? It's just a straight line, nothing else.
Simple.
Right. And decision tree like makes a whole tree and then
Random
goes
forest.
up and the choices for linear regression and decision tree.
Okay.
Yeah,
That means
yeah.
the difference is more
Yeah.
complex.
Yes. So that's the first view that the model has over, decision tree will have high variance, linear regression will have high bias. Now, you can also determine it after training on some data, sample data. Like if the train performance is too low, it underfitted. If the train performance is too high and it is not doing well on test, then it overfitted on the train data. But the general rule of thumb is before training, how would you know? This is how you know. Like random forest is better than this is better than this is better than this.
So can we relate this as in the difference between the actual output and the output which you are getting? This difference, this actually defines the bias.
I'm sorry, I didn't get you.
So can we relate this as the difference between the actual output which we should get and the output which we are getting? So the difference between these two values should be our bias.
Okay. Yeah. So you are saying like train, like CV value, cross validation value, and like test value. Right. Test value would be your real world value, and train value would be your like CV value, cross validation value. So in case of bias, the train value, the accuracy, AUC, whatever, would be very low. And sometimes you would see that the test is performing better than train. You tell me like is to some extent this is okay, but you tell me does this make sense? That train accuracy is 20, test accuracy is 60, sometimes 60, sometimes 50, sometimes 19, right?
Okay.
So here also you can see there is bias because it did not train well on the train data. That is why the test data is very volatile. And it can be easily higher than the train accuracy as well, which should not happen. Should I move forward or do you have any more questions?
So we should have less bias, sir, right?
You should have, so there's a term called bias variance trade-off. So the model should not be too complex or the model should not be too simple. Too simple meaning bias, high bias.
Okay.
So you need that like middle point. Not too complex, not too simple.
Okay. It means it should exist, but not to a large extent.
Yes, then it would go like, it would become complex. Then you are having a problem of overfitting. Right. Okay. Then let's move on for now. Okay. Third question is explain collaborative and content-based filtering, which are used in recommender systems.
Not exactly, sir.
No, sir.
Can I guess?
Yeah, you can guess.
I think context-based recommendation system gets the figure out the data and its value. I think something.
Like how will you state in recommender system, how does it relate? Like, how does your statement relate in case of like recommender system? Recommender system is basically what Amazon does to all of its products. Like, you may also like this, buy this more.
Hello, sir.
Yeah, right.
I think, sir, yeah, we learn also. I think content-based filtering. I think हम लोग प्रोडक्ट का जो फीचर्स होता है, जैसे किसी में सिमिलर फीचर्स हैं, तो उसके बेस पे हम लोग डिफरेंशिएट करते हैं डाटा को. और आई थिंक कोलैबोरेटिव लर्निंग में आई थिंक हम नॉट प्रोडक्ट बट डिफरेंट मतलब यूजर का कैसा फीडबैक है, रेटिंग है, उसके बेस पे हम लोग सर आई थिंक चीजें देखते हैं सर.
Okay, so the second part is right. The first part is like half right, I can say. So basically, this, yeah. In collaborative filtering, as he said, it is a method which takes preferences of many similar users and gives a recommendation. For example, me and Devendra like bought many similar products, right? I bought a toy, he bought a toy. I bought Alexa, he bought Alexa. Now, if I buy something else, right? I buy a book about someone, and Devendra has not bought a book of that exact nature, then he would get the recommendation of the book because we are similar in preference. So basically, how friends work, right? If your friends have like good music taste and you have similar music taste, if a friend recommends you someone some music, that is basically collaborative filtering. Because you have the same taste and someone recommends you, then you would also mostly like it. Content-based filtering is on the attribute of items. So as you said, on the product features, suppose I'm buying a phone. So I would see what's the RAM, what's the ROM, what's the screen size and everything. But it also analyzes your past history, right? So if I bought phones and earphones and this and that, electronic items, so it sees my past history and recommends me some more electronic items. Right. So that is basically content-based filtering. So collaborative is based on preference of similar users. Content-based filtering is based on the attribute of items as well as your past history. So here's a quick diagram on it. Collaborative filtering, if she and he have read the same newspaper and they are similar users. So if she reads a new newspaper, this will be recommended to him because they are similar in nature. In content-based filtering, if he reads anything, any newspaper, so the content-based filtering will find similar newspapers or articles. Like this is a similar article and it will be recommended to him. Okay. So anyone has any questions in this or should we move ahead? Okay, the next question is, what are the key differences between random forest and decision tree? So this I have faced myself in the interviews very much, like too many times. To be honest, everyone kind of has, every interviewer has a point in their head that they want you to speak. The best thing for you to do is know 90% of the points, like what are the key differences, right? So who will start the key differences?
The key difference, the main difference is the decision tree works on a single algorithm, and the decision tree, this random forest is the collection of the different decision trees.
Okay, that's a very good point. That's a major point.
Yes.
Next.
So in decision tree, there are chances of overfitting is much more rather than the random forest.
Okay, that is true. So when you say that, why does random forest has a less chance of overfitting? So you will get a follow-up question like this. When you make a claim, this does not overfit. Why does not it overfit? So you remember bagging, right?
Yes, sir.
Yeah. So random forest is the first and foremost example of bagging.
Bagging. Yes, sir.
It takes like n number of decision trees, trains it in parallel, and gives you a result by voting. That is nothing but random forest.
Yes.
So, and bagging and boosting reduces variance. Okay.
Sir,
Okay. That. Yeah.
a decision tree is like a tree, just like a normal tree, and random forest is the group of decision trees.
Okay. That was his first point, but yeah, that is true.
Sir,
So we have 2 points right now. Random forest has less variance, and random forest has the collection of decisions. What's more?
sir,
Yeah.
I think, sir, because of because random forest, we have many decision trees. So I think decision tree is more fast compared to the random forest. Sir. On the
Yes,
large,
training time. That's a very good point. Yes. Training time is better in decision tree. What's
yes.
more? So we have 3 things now. What's more? What's more? We'll stop at 4 or 5. That's good.
Sir,
Sir,
training
the accuracy of the random forest is much more because we can have the different options. We have
Yes.
different.
You are saying accuracy is more because we have different options. Okay, that
Sir,
is like piggybacking.
sir, we can have different, we can train our random forest, different decision trees of the random forest with the different hyperparameters. We can have the tuning in that.
So
Yes.
decision tree doesn't have hyperparameters.
I think we can say that a decision tree is easy to visualization because it's like a single tree, and random forest is more complex visualization.
No, see, like that is just training time you are saying. You can't say it is difficult to utilize. You are just importing it from the same sklearn library. Right? You just do import sklearn.random forest as rf.fit. That's it. Like it's not complicated to you. So the point here you would say is the training time. You can say it's complex and all, right? Proceed by saying that is why it has more training time than decision tree. And like in production environment, you need to do things quick. So you might not
Sir,
choose random forest.
Sir, also decision trees results are not accurate, but random forest getting accurate and precise results.
Correct. Yeah, that comes on the bagging point because it have a lot of decision trees. So it can take like accurate decisions because there's a voting scenario. Decision tree, a decision tree has just one tree which votes, like 1 or 0 in a binary classifier. In random forest, 10 or 12 or 1,000 different trees vote. What should be the output? And then you get an output. Right? Okay. So let's on to the answers. Number of trees, as many of you said, right? Number of trees in random forest is more. Decision tree has 1 tree. Ensemble method. Random forest is an ensemble method. It uses bagging approach, right? And each tree in random forest is trained on a different subset of data. So that reduces the risk of overfitting. And that improves the accuracy of the model. So you have to like frame your answers like this because you will get follow-up questions. Right?
Hello, sir.
Yeah.
Sir, which kind of problem we can solve with random forest and or decision tree, sir? How we can decide like we have to apply random forest particular for this problem?
So the rule of thumb is if you have like data set of over 10,000 or something points or 1 lakh points or something like that as a threshold, you should use random forest. If it is lesser than that, you should start by using decision tree. because decision tree does not really tend to overfit on less data. If there's more data, it just tries to find complex patterns and noise, which is not required.
Okay, sir.
So for
Thank you.
smaller data sets, decision tree, bigger data sets, random forest. Okay.
Yeah, thank you, sir. Thank you, sir.
Okay, ensemble method we did. Bias variance trade-off. So decision trees has a high variance. Right. That just means it can easily overfit on training data and perform very poorly on the test data. Random forest reduces this problem because it combines like various trees, and with the help of bagging and routing mechanism, it reduces the variance. Right. Bagging and routing mechanism, but in bag, if you say bagging, just remember to say it separate samples of data go in each tree. That is why it is like non-biased, right? If everyone gets the same samples, everyone will say, "Acha, this is best, this is best." But you should give different samples of data to each tree. Then you will get multiple results, right? And it reduces variance and improves the overall performance of the model. Feature selection. So in decision tree, this is a very important part. In decision tree, algorithm just selects the most important feature, and it splits the data dependent on that, right? But it could not be always the most optimal feature, right? It could be a good feature to split. It could not be the most optimal feature to split on. But in random forest, because it randomly, gives the subsets of features and data at each node, it increases the chances of selecting the optimal feature. Like 100 बार में से 7 या 8 बार तो they must have the decision trees in the random forest must have selected the optimal feature. And because of this, it improves the overall accuracy of the model. And the last point is trading time, right? I guess that's it. So decision trees are simpler, faster to train. Random forest is more accurate and robust due to ensemble method, feature selection, and bias variance trade-off. Right. Does anyone have any questions on this, or should we move on? So we are moving on. Okay. What is AUC, ROC curve, or like what is AUC first of all?
Sir,
And where is it used?
area under curve, and
Okay.
it is used when we are checking the performance of our model. That if the area under curve is more than our accuracy, our model is working in a good direction.
Okay, that's right. What kind of problems do we do? Like classification problems, regression problems? What kind of problems do we use AUC in?
Sir, I think it is in the regression problem.
Regression problem. We majorly use in regression problem.
Regression problem, yes, sir.
Yeah, no, I like how you two gave the wrong answer at the same time, but it is used in classification problem. Okay. So when you say area under the curve, what curve are you referring to? What curve? Right. If I'm an interviewer, I would ask you, if you're saying area under curve, like what curve? This curve, that curve, parabolic curve, like what curve?
Basically, it's a parabolic curve, sir.
No, sir.
Okay. No, like
No, sir. That
I'm
is
not
not
asking the shape. It could be a parabolic curve. It could be like a linear thing. Like it doesn't matter. But what is the curve name? So there comes ROC. So basically, receiver operating characteristic curve. Okay. It might sound very.
Sir, please
heavy.
repeat it. Sir, please repeat it.
It is receiver operating characteristic curve.
Okay.
And AUC is just the area under that ROC curve, receiver operating characteristic. Okay, and it is used in binary classification. Okay.
Okay, sir.
So, does anyone have anything more to say about this? Like, how is it calculated? Like, any general idea?
सर बेसिकली आई थिंक मतलब हम डिफरेंट वैल्यूज के ऊपर हम लोग सर चेक करते हैं, थ्रेशोल्ड वैल्यू के ऊपर हम लोग चेक करते हैं मॉडल कैसा परफॉर्म कर रहा है.
What are those threshold values you are saying? Like what values of what?
Like
Those are prediction. Those are prediction values. Like you are right, but you should say different thresholds of predictions, not values. So if you like seem vague in the interview, they will like point to it and go inside it. Right. And then you can't answer. Like if you don't know what are those values, you can't answer. So I always say if you are answering something, try to like incorporate everything you know in that one answer. Right. So like if you don't know anything, you can say whatever you know. But if you know, then try to incorporate in the first answer so you don't get many follow-up questions. Because in the follow-up questions, they just dig deeper and deeper and deeper. Like predictions, what predictions? Predictions to I nahi. What do you mean by predictions? If you have predictions, why would you measure performance? Right? Why don't you do accuracy? Right? So try to do like it is various thresholds of predictions. Right? And you were right. On basis on this, we make a curve. Right? And we find the area under that curve. And now we will see how does it actually work. It is very simple, to be honest. AUT ROT curve is basically area, like the whole thing is set area under the receivable operating characteristic curve. Or just area under the curve and receivable operating characteristic is the curve name. Right? It is performance measurement for binary classification problems. And ROC is basically a probability curve or the prediction curve. And AUC measures how much your predictions are separated, how much your classes are separated. For example, you have two classes, right? Suppose like cancer and not cancer. And you need the predictions of these to be very separated. Like it should not happen ki maybe cancer, maybe not cancer. It should not happen like that. Right. So these two classes should be very separated in predictions. And higher the AUC, the better it is. Like predicting 0 classes as 0 and 1 classes as 1. A good AUC would be closer to 1, right? Which means it has good measure of separability, right? So if you need to, so you say AUC is a performance measurement tool and it should be high, right? But what if they ask, acha, like what is AUC doing that accuracy is not doing? What will you say? So the answer is this. It measures how much your classes are separated. The classes meaning suppose like cancer and non-cancer, right? A poor model would have the worst separability. Like it would be like maybe cancer, maybe not cancer. And you can't really do this in real world. Right? People are really suffering. You can't say that acha, it is maybe this or maybe that. Right? You would just be fired, to be honest. So it should be high. So higher value meaning it has good like separability, the two classes. So if your prediction is saying it's cancer, it is like 99% sure it is cancer. So we are not giving any inaccurate diagnosis or anything, right? And in AUC, always remember if AUC is 0.5, that means the model has no class separation capacity. That just means like it's just a coin flip, 50-50%. The model is like 50-50% thing. Maybe it will predict like properly, maybe it won't. So the curve looks like this. Okay. In the x-axis we have false positive rate. In the y-axis we have true positive rate. So technically false positive rate should be as low as possible. And true positive rate should be as high as possible. So if you see this point, this is like a perfect classifier because false positive is 0 and true positive is 1. Right? But it won't ever happen because an ideal model does not exist. So if you see this line, this is a random classifier. This is a 0.5 mark. If you see the intersection here, it is 0.5. This is just a random classifier, basically a coin toss. That model does not help anyone. You can just do a coin toss yourself and pick the result. Now, the better the curve, the better the model is. Because just understand it, if the curve is like this, the blue line, the true positive rate is very higher and the false positive rate is very low on the curve. Okay. So this is like the best model. So if you see the green one, so the curve point is here, right? The true positive rate is lower than this. It was close to 1. Now this is like close to like 0.5. And the false positive rate also increased, which is bad. So when you say area under the curve, what do you think? Which curve would have more area under it? Area under basically this value, like this area. But what do you think? Which curve would have more area under it? The blue one or the red one or the green one? Or the yellow?
Blue one, sir.
Blue one, correct. Yes.
Blue
So
one.
that's how you understand what it is. You can say area under the curve everywhere. Every applicant, job applicant would know it, right? And the higher it is, higher the performance. But if you know this thing, right, how does it work? It is actually a curve. And here the true positive rate is higher, false positive is lower. So that is why the area is much more inside the blue curve. And that is why your model is the better model than the green or the yellow or the red. Okay, the last question is, what is hyperparameter optimization, and name some techniques to achieve the same. Let's start by what is hyperparameters, and then you can explain hyperparameter optimization.
Sir,
What are hyperparameters?
Sir, hyperparameter is by changing these parameters, we can change the performance of our model.
No, I'm asking like what are hyperparameters? You answered the optimization part, right?
Yes, sir.
By changing it, we can optimize our model. That is correct. But what are hyperparameters? And how is it different from normal parameters? Like, what is the difference between hyperparameter and
Sir,
parameter?
hyperparameter that we can vary.
Okay, do you mean hyperparameters are the
We-
parameters we can change?
We can change on which we have the control.
Okay. Okay, another good way of putting it is, that is true, you could say that, but you
Sir,
should always think
we
about,
can say
yeah.
we can
Go
say
on.
in hyperparameter, it's a parameter which
Value is used to
resembles
control the
range,
learning process.
in which we can pass range, then it has helps to achieve a good accuracy.
Hello, sir.
I just
I
want
think-
to say to the last answer, you just explained optimization part, hyperparameter optimization. My question is, what are hyperparameters?
Sir, hyperparameter
Yeah, go ahead.
is a parameter whose
Sir.
value is used to control the learning process.
No, that, okay, what is the difference between hyperparameter and parameter of a model? Like, what is the difference then?
Sir, generally, hello.
Sir, hyperparameter means by changing these parameter, means minutely changing this parameter, we can have the much variation in our output.
No, you are again, like, you are explaining the optimization part,
Okay.
right? When you say varying these, you get different outputs and you get better outputs. That just means optimization, right? Previously you got 50% accuracy, now you get 80% accuracy because you change parameters.
Okay.
I'm asking, what are hyperparameters and how is it different from like normal parameters of a model? Yeah, Devendra, you were saying something in between.
Yes, sir. So I think, sir, suppose you want to increase the accuracy level of the algorithm, then we are using some hyperparameter like weight, so that we can do fine tuning basically, so that we can increase the accuracy level of the model, sir.
That is again like hyperparameter optimization. Say, if you can explain hyperparameter optimization, but if they ask what are hyperparameters, then you are stuck. You don't know what are like.
So
The one good explanation I heard was that these are the parameters that you can manually change. Right? That is one correct explanation. The second most important explanation is these are the parameters that the model itself can't learn. You have to provide it.
But
It
we can
is
say it's a part of a model, or another is external to the model.
no, it is a part of the model. Model.
Okay.
So again, like what is the difference between hyperparameters and normal parameters of the model? Hyperparameters are the ones which you can manually change, and the model cannot learn it by itself. Yeah.
Yes.
The model can learn the parameters by itself, but not the hyperparameters by itself.
Okay, that's why
Yes,
we do
sir.
hyperparameter tuning later on.
Yes, sir.
Yes, correct. Correct. Yes. So basically, you can imagine a circuit box. So the light switches and fan dials would be the hyperparameters, which the circuit board can't change itself. But the internal wirings and how it is handling the stuff behind are the parameters which it can change itself. The circuit board can analyze what do I need to do to get the fan on and at this speed. Those are parameters. Okay, it can learn that.
Yes, sir.
So basically, yeah, hyperparameter the parameters used to control behavior of the algorithm, right? These parameters cannot be learned by training. They need to be assigned before training them. And some examples of hyperparameters would be like n neighbors in KNN for max depth in decision tree classification. Hyperparameter tuning is basically a process by which we determine the optimized combination of hyperparameters by which the model performs the test, right? And it always runs by training multiple times. The model trains multiple times on different hyperparameters. And each time is a complete training of the model. So the last point basically means each trial is a complete execution or the complete training of the training application, which basically means model. Okay. And for the chosen hyperparameters. Now, the second part of the question, who can tell me some basic techniques to achieve hyperparameter tuning?
The gradient descent.
Gradient descent, see, if you say something like gradient descent in a machine learning interview, you will be expected to answer it. What is gradient descent and how does it work in a hyperparameter optimization, which is very hard. Okay, even for me.
Okay.
Right. You should stick to simple thing.
Okay.
You can do hyperparameter optimization using AI, but no one in the industry does that.
Sir, in that case, grid search.
Okay. One, good. Anything else? Okay, well, how does grid search work?
Sir, it will see the results for a range of the parameter and then it will decide which one will give the best result.
No, that to every hyperparameter optimization technique does. I'm saying, what does grid search do? Okay, so
can we consider it for finding a p-value considered as an hyperparameter tuning?
Finding a p-value considered as a hyperparameter tuning. No, hyperparameters are model hyperparameters, not a statistical measure such as p-value.
Okay, then finding out the value of alpha, lambda, and the number.
Like sir,
Yeah.
like elbow method.
Yes. What elbow method? See, again, like if you give complicated answers, it will just tell the interviewer that you know complicated things.
Okay.
So, sir, as far as I know, whenever I use KNN algorithm, so we go for only hit and trial method only. Because
But hit and trial grid search you are saying, or like is that a proper technique you're using grid search, or just just manually changing? Like
so
every time you just go to the same fit method and just manually change everything.
No, sir. Grid search.
actually, sir, I don't have any idea regarding the grid search.
Okay. So you should not do it manually. I have to do it manually as well long ago, but you should not do it manually. So there are very good techniques for it, as Ruchi said, grid search. So the simplest two techniques, the simplest, right, which answers the question, like give examples of hyperparameter optimization technique, is the first the grid search method. So what it does, it creates a grid of all the possible values, right? Now it tries every combination of hyperparameters, right? Suppose the first hyperparameter had, I gave like 3 values, 10, 100, 1000. Then this is like 0.1, 0.2, 0.3, and blah, 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 whatever, right? Now grid search will try every possible combination of like this and this, 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 every
Sir,
combination.
So that's what I told, no? In grid search.
No, your answer was half right because it was very big. What you gave answer basically told us that, acha, this is grid search. We have like every value, like every combination, and we try combinations, and we see what is the outcome. Every hyperparameter optimization technique tries combination and gives you an outcome. Every hyperparameter technique, right? But in grid search, you go in a specific order and you try all combinations, all the combinations, right? Now, for an example, let's give you the second, which is random search. Random search, it also creates a grid of all possible values. Now, here, each iteration, you try some value randomly, right? You pick like 1 from here, 1000 from here, 0.5 from here, and do randomly, right? And then you find the best possible result based on this. So the difference between here is, so suppose here there are like 1000 trainings because it tries every possible value, right? It goes into factorials and now random search, you can define how many iterations should you run. Like suppose I said I only want to run my model 50 times and not like 1000 times based on the same hyperparameters which I gave you in a grid. So it will randomly pick out some hyperparameter value and train on it. For like, and it will repeat this process for 50 times. Like the next iteration, it will again randomly take some values. Next iteration, again it will randomly take some values and do this for 50 times. And not 1000 times which grid search was doing. So what is the major advantage and disadvantage of grid and random search?
Sir, I guess grid search CV will give the better accuracy
Okay.
because
Yes, go ahead.
Yeah, it tries every possible combination, right?
yes,
Yes. And what is the disadvantage of grid search?
it takes time.
Correct. It takes like, as I said, 1050, right? It will train for like 1000 iterations, which is a lot more time than training it for 50 iterations, which is done by randoms. And you can tell the random search how many times you want to run. It can't be like just 50. You can say 20, 100 times, 150 times, whatever. It's up to you, right? And so these are the most two basic examples. The third, which is like semi-basic, is like Bayesian search. I will explain to you simply. It has a very complicated formula. So the basic funda of Bayesian search is grid search takes more time, but does a better job. Random search takes less time, but does a worse. So Bayesian solves this problem. What Bayesian says is, I will train the model one time, right? And I will learn from it, like which hyperparameter gives more result, like better result, which is contributing more. And then it learns from it and then does the second iteration. And in the second iteration, again it learns. Acha, what hyperparameters give better result now? Like which hyperparameters are contributing more in a good way, right? So this is basically Bayesian search. It solves the problem of grid and random search. It takes relatively less time than grid search. It gives more accuracy than random search. So it is like somewhere in between because it learns after every iteration, right? So does anyone have any questions on that?
No, sir.
Okay. I think that was the last question, and that is it from me for now. If you have any other like general questions as well, you can ask me. Otherwise, I guess we can close this sentence.
Hello, sir.
Yeah.
Sir,
Hello.
I have one question. Basically, like we have a linear regression, we have a logistic regression, right? Linear regression, actually, we are finding like constant value, right, sir? And in logistic regression, basically, we can solve the classification problem, like yes,
Correct, correct.
true and false. So why we are calling this logistic as a regression, sir, not classification?
Okay, that is a very good question. So basically, what is linear regression? You must have seen a line, right? Just a straight line, like y equals to mx plus c line, right? Now, what logistic regression, why is it called regression, is because it uses the linear regression methodology. It just tilts the above line in a S curve. If you have seen the graph of a logistic regression, there's a S curve, right? And the middle part of that S is nothing but a linear regression line. It is just the above and the below parts are just bent, right? So that is why it uses like linear regression methodology. And the closer it is to the upper part, it will say the classification is 1. If it is on the lower part of the graph, it will say on the line, it will say the classification is 0, right? It is just linear regression. We have bent the graph a bit, the line a bit, and we are using it for classification problem. That's the only difference, and that is why it is called like regression.
Sir, I would like to add something here. And so in linear regression, we find the best fit line by y equals to mx plus c, right?
Correct.
In logistic regression, we also do the best fit line, but in that case, our best fit line, put it to the equation to the sigmoid function, which is 1 upon 1 plus e to the power minus x.
Correct.
And then from that, we get the values lies between 0 to 1, where
Correct.
0 is like no, and 1 is like yes. And in this case, if the value lies between 0 to 1, and if the value suppose like comes out to be 0.5 or above than 0.5, then it's considered to be a 1. And if it lies between 0.5 or less than 0.5, then it lies to be a 0.
Yes, that is correct.
Difference.
No, that is not the difference. So it is, it is theoretically, that's the, like, if you're comparing models, then that's the difference. But if you say why is it called regression and not classification algorithm, like SVC, it's a proper classification algorithm, right? You must have seen logistic regression, right? It is basically linear regression, but the ends are bent. Now you can just use linear regression. That is also fine. You can use linear regression for classification. Do you know what would be the problem with it?
I guess.
So you would get here infinity plus infinity value and negative infinity value because the line just goes on and on. in logistic regression, as you bend the lines, the lowest value you can get is 0. You can't say your prediction is minus 1.5. That does not make sense. But the logistic regression takes care of it by saying, acha, like even if you go negative, it is just 0 because it has bent that line at that axis, above and below. If you go like plus 1.5 or something, it will say it's like 1. There is no 1.5. There can't exist any 1.5. Right. So that's like the main reason, because like regression, why is it called regression? Because just use this linear regression and just bend lines on that. But if someone asks you what is the difference between models, then your answer is the perfect answer. Go with it. It uses y squared times x plus 3. This uses 1 upon 1 plus e raised to minus 6.
Okay.
Okay. So 2 different answers for 2 different questions. Nothing else. Does anybody have any other questions regarding jobs, interviews, interview questions? Okay, no one, it seems.
No, sir, not right now.
Okay, sure. Then
Yeah, okay, Suraj, I think it was quite insightful, and I hope it was very much beneficial for all the students. They learned quite many things. They were able to clarify their doubts. So I think it was very useful session for each and everyone. And if required, these people will contact you. I will collect the questions from these people and pass on to you. Okay, and you can guide in future. That kind of support we would definitely expect from you. So thanks,
Yes.
Suraj, for your time, and yeah.
Yeah, thank you, sir. Thank you, everyone.
Thank you,
If
sir.
there's any,
Thank you,
if
sir.
there's any question, just ask
Yes, sir.
sir. And it was great having this session.
Yes.
Same here,
Yes,
sir.
sir.
Thank you.
Same here, sir. Thank you.
Okay, thanks, Suraj. Thanks, everyone. Okay, bye, bye.
Bye.